Today we're going to take what we did yesterday and we're actually going to apply it to write out a formal proof. So the thing about proofs is it's kind of like what we were talking about yesterday. You need a statements and a reasons column. So the statements are going to be the steps that you are taking to get through the proof, and the reasons are going to be any theorems or postulates or rules that support what you're saying. So it makes more sense as we work through it, so you kind of have to bear with me here. So in the first proof, this is a really important one. We talked about last chapter how angle 1 and angle 2 in this case are what we call vertical angles. And one of the things that I taught you guys is that vertical angles are congruent. So up till now, we just kind of use the rule, hey, they're congruent because Mrs. Stoltz said so. So what we're actually going to do today is we're going to write a proof as to why that's the case. No matter how you draw any crisscrossing lines, these angles, these vertical angles, are always going to be congruent. So with any proof, you must always restate the given information, and the purpose of that is for clarification. You don't want to assume that the reader who's reading your proof knows all the given, so you have to tell them what was given. So we're going to start by writing that angle 1 is congruent to angle, angle 1 and angle 2 are vertical. And for the reason, we just write, again, given, kind of like we were doing yesterday. And you always want your last line to be what you were asked to prove. So you were asked to prove that angle 1 is congruent to angle 2. Don't know the reason yet, but we'll get to it. So if I'm asking you to prove that angle 1 and 2 are congruent, you don't want to start off by saying, because they're vertical angles, they're congruent, because that's what you're actually trying to prove. It's kind of like if you go into a cell phone store and the salesman's like, oh yeah, this is the best cell phone we got. And you say, why? And they're like, because it just is. That's not very much of an incentive for you to buy that cell phone. You got to be able to back what you're saying up. So we have to keep in mind our end result is we want to get an equation built up, and I want to have 1 or angle 1 on one side and angle 2 on the other. So an equation that I could make from this picture is I could say that angle 1 plus angle 3 equals 180. And the reason I can do that is because those are supplementary angles. I can see that from the picture. Some people also will write because they are a linear pair, which means they make a straight line. So either reason would be appropriate for this case. So we've got angle 1 involved. Now I need to get angle 2 involved. So likewise, I can go ahead and say that angle 3 plus angle 2 also equals 180. And that's for the same reason. They're supplementary angles, or they form a linear pair. But the good news is I don't need to recopy this reason. I'm just going to put quotation marks. And what those quotation marks allow, or what they mean, is the exact same reason as directly above. So since supplementary was above, and that's our same reason now, I don't need to recopy it. I can just put quotes. Now, if my reason here was given, I'd have to write it because given is not directly above, it's to above. So our last statement, it can be a little tricky, keeping in mind I want to have angle 1 on one side of an equals, angle 2 on another. So the other way I can do that is if I take this group, angle 3 plus angle 2, and I am going to actually substitute it in for 180. So you have to kind of think about that for a minute. Angle 3 and angle 2 make 180, so in this equation, it's like I can kind of erase the 180 and replace it with the expression. And that's exactly what I'm going to write in step 4. Angle 1 plus angle 3 equals angle 3 plus angle 2. And keeping in mind, what we did is we plugged in an expression for a number, and that would be our substitution property. What I can do then, and we have to remember that these are really just mystery numbers, right? This is the measure of angle 1, measure of angle 3, measure of angle 2. Well, I can subtract angle 3 from both sides, since it's really just a number, and what's going to happen is it's going to go away. It's going to become 0, and I'm left with angle 1 equals angle 2. So to get from step 4 to step 5, I had to subtract off angle 3. So that's going to be using the subtraction property. So that's what we call the vertical angle proof. You just proved that vertical angles are congruent, because we could repeat this proof for the other two pair of angles as well. All right. In our next proof, we have quite a few givens. We have that angle 1 and 2 are complementary. Angle 3 and 4 are also complementary. And angle 1 and 4 are congruent. So the first thing I want to do is make my markings in the picture, just as I've done, and then I have to restate my given. Now, when you restate your given, it's up to you. Since we're told more than one thing, you could use 3 lines, one for each given, or you can smush them all together on one line and write given once. It really makes no difference. So I like to actually smush mine together. So we're going to have to write angle 1 and angle 2 are complementary. Angle 3 and angle 4 are complementary. And angle 1 is congruent to angle 4. So we need to state that that was all the given information. And since you're asked to prove that angle 2 and 3 are congruent, that needs to be your last step. And actually, this is going to turn out to be a 6-step proof. So we can just kind of cross out that bottom line. It's only going to take 6 steps to get this done. An equation, because I need to get 2 and 3 on opposite sides of an equals as my last step. And one equation I could make is I could say that angle 1 plus angle 2 equals 90. And I could also say angle 3 plus angle 4 equals 90. Now the tricky part is figuring out the reason that we're writing that. And the reason is actually going to be because of the definition of complementary. And if you think about it, it makes sense, because if you didn't know what complementary meant, you couldn't write that equation. So since it's the same reason, I can go ahead and put quotation marks. And then just like we did in the other proof, since this expression equals 90, I can plug this expression in for 90 above, which allows me to write angle 1 plus angle 2 equals angle 3 plus angle 4. And just like before, we call that the substitution property. Now this is a little different than what we did before, because I have 1, 2, 3, and 4. So it's not like I have some 2 things that are the same on each side that I can just subtract off. So there has to be something I can do so that I get the same number. And I actually haven't used the fact that 1 and 4 are congruent. So what that means is I can plug 4 in for 1, or I can plug 1 in for 4, and it's not going to make a difference which one you do. So I'll change 1 into 4, Again, since they're congruent, I can change them in and out as I please. Again, that was substitution, so I'm actually going to put quotations. Same reason as directly above. And by doing that, I now have angle 4 on both sides of the equals, and I'm allowed to subtract off from both sides so that it ends up becoming 0, it goes away. So our last step is going to be the subtraction property. 3 and 4 are supplementary, and angle 2 is congruent to angle 4. So I'll just go ahead and put little rainbows in there to show they're congruent. So I have a visual. And again, I'm going to recopy all my given. So go ahead and do that. Okay, so we have all of our given information down. And we have to remember we're asked to prove that 1 and 3 are both the same measure. We want to prove they're congruent. So I need to start by creating some equations. Eventually, I want 1 and 3 to be on different sides of the equal symbol. So I'm going to use my first piece of given here. Since angle 1 and 2 are supplementary, that means they must add, make 180. And it's kind of the same case with angle 3 and 4. So we'll go ahead and do that. And our reasoning for that, the reason we know they add to make 180 is because we know what the definition of supplementary is. So you want to write definition of supplementary. And since it's the same reason below, let's put quotations. And just like we did before, this whole group is equal to 180, so I can plug this whole group in for 180 above, which will let me write angle 1 plus angle 2 equals angle 3 plus angle 4. And that we called substitution. Now again, we're trying to prove that angle, oops, go back down here. We're trying to prove angle 1 and 3 are congruent. The problem is I have 2 and a 4 here, and I haven't said they're the same angle, so we want to do that next. You either have to plug 4 in for 2, or you have to plug 2 in for 4, since they're the same. So I am going to plug 4 in for 2. And again, we call that substitution. And by doing that, I can take off angle 4 from both sides. And look what I'm left with. Angle 1 equals angle 3, thanks to the subtraction property. So we actually didn't need step 7 in there. And you just go ahead and cross out that line. Okay, so we have another proof going on here. We're given that angle 1 and 4 are congruent. So even though it says don't start with the given statement, I'm still going to start with the given statement because that's a good habit to get into. You always want to restate your given. And we are trying to somehow prove that angle 2 and angle 3 are equal. So this is actually going to be very similar to the proofs that we did before. I can see from the picture that angle 1 and 2 make a line, which means they're going to make 180. So again, we could write supplementary for that, or we could write linear pair. And the same thing with angle 3 and 4. And just like we did before, we're going to plug in this group for 180. And we'll have angle 1 plus angle 2 equals angle 3 plus angle 4 by substitution property. And since these are all different, there must be something I can replace so that I can do some subtracting. And since angle 1 and 4 are the same, I can change them in and out as I please. And again, that's just substitution. So it looks like we're going to need a sixth step. So I'll just go ahead and add a line down here. No big deal. And now I can finally get rid of that angle 4 by subtracting it off, and I get angle 2 equals angle 3, thanks to the subtraction property. Okay, so let's go through and start the next one. Angle 1 and 2 are complementary. What else is given to us? Angle 2 and angle 3 are complementary as well. And we're supposed to prove that angle 1 equals angle 3. So we want to start creating some equations. Let's go ahead and write that angle 1 plus angle 2 equals 90. And angle 2 plus angle 3 equals 90. Just like before, the reason I know that is because I know what the definition of complementary is, which means adds to 90. It's the same reason for the below step. Just like before, here we go. We're going to plug in this expression for 90. Should be getting used to this by now. We're going to write angle 1 plus angle 2 equals angle 2 plus angle 3. And that was substitution. I now subtract off my angle 2 and I get angle 1 equals angle 3 by subtraction property. That's what I was asked to prove, so I know I'm done. So it looks like, again, I didn't need this last step here, so we'll just cross that out. All right, the next proof is actually more algebraic. So it looks like we're given that C is the midpoint, so let's write that down. Okay, now, since C is the midpoint of AB, I have to think, what do I know from that fact? I know that from A to C has to be the same distance as C to B. And the reason I know that is because I know what the definition of midpoint says. The definition of a midpoint says that it is the point that splits a line in half, so then each half must then be congruent. Now, since AC is equal to 2x plus 1, I'm actually just going to plug that in here. I'm actually going to say that 2x plus 1 equals AC. Even though they didn't write that up here in the given, they put it in the picture. So if they put symbols in the picture, if they put information in the picture, you have to count that as given. So I'm going to jot that down. And while I'm at it, I'll also throw in that 3x minus 4 equals BC. So I've got the written part of the given, what they put in the picture. I've stated all my givens. I'm all right. And it's okay that I have AC equals CB as my step 2. Usually we write the givens first, but I didn't need to know what I wrote in step 3 to do step 2. That they have nothing to do with each other, so we're okay. What I want to do next is I actually want to plug in 2x plus 1 for AC, and I want to plug in 3x minus 4 for BC. And now we're going to go through and we're going to solve our equation for x, and we're going to prove that x comes out to be 5. So it looks like I'm going to subtract 2x from both sides, leaving me with 1 equals x minus 4. Again, we subtracted. And I think we may need some extra steps here. Yeah, we do. Okay. And then 6. Looks like to get x alone, I'd have to add 4 to both sides, which would give me 5 equals x. And we will call that the addition property. And just to be nitpicky, they said prove that x equals 5. So I want to switch it and put x on the left. And the property that says you can switch sides of the equals is the symmetric property. All right, and that's it for that proof. So the good news is we're almost done. We have one more proof to do. So bear with me here for it. All right. So with this last proof, before I start, I just want you guys to know that I really appreciate you being cooperative with this, and I know that proofs aren't the most exciting thing in the world to do, but it is a necessary part of geometry. So we do have to stick with it. But before we begin this proof, I'm going to give you a little challenge, all right? And I'll know if you're really listening to the video or if you're just fast forwarding through it and copying the answers. So if you're listening to this video, here's a challenge. Go next door after class to Mr. Rigner's room. He's a teacher right beside me. And ask him what his wife's name is. Okay? So when he tells you his wife's name, I want you to write that down on the back of your homework tonight and then show it to me on Monday. And if you do that, I'll give you a 3-point extra credit pass, and you can use it on any future assignment. So we'll see who's really listening and who's not listening. All right, so last proof. Segment, or looks like ray BF bisects the angle. So I'm going to write that as a given. I also have 2 more given things. Not up here, but in the picture. they tell you that angle EDF equals 2x plus 25, and angle FDG equals 5x minus 5. So they actually have 3 pieces of given information in here. Have to pick up on the picture sometimes. So what I want to start by saying is, and I'm going to tell you guys what, I'm going to put a 1 and a 2 in here because I just don't feel like writing all those letters all the time. I'm going to go ahead and say that angle 1 is congruent to angle 2. And the reason I know that is because it said that this angle is bisected. It is split in half, which is definition of bisect. So instead of calling this angle EDF, I'm calling it angle 1, just because I'm too lazy to write 3 letters, and there's nothing wrong with that. You can always name them by numbers. That's fine. So what I'm going to do now is I'm just going to substitute. Instead of angle 1, I'm going to plug in 2x plus 25 equals, instead of angle 2, I'm going to plug in 5x minus 5. And plugging in, we should get used to this by now, is called substitution. And it's up to you what you want to do first in this step. You can either, subtract 2x from both sides. You can add 5 to both sides. This order does not matter. I'm going to choose to add 5 to both sides. And if I did that, I get 2x plus 30 equals 5x. And adding 5 means I've used the addition property. It looks like I'm going to have to subtract 2x from both sides. So I'll have 3x over here. Thank you, subtraction property. And my last step is I need to divide by 3 on both sides, which would give me 10 equals x. And that was the division property. And I guess since our proof technically said proof x equals 10 instead of 10 equals x, I'll just go that little extra step and change this to x equals 10. And that property that allows me to switch sides of the equals is the symmetric property. So there you have it. We just wrote our first official proofs in geometry. Hope it was fun for you. I know it was super fun for me. And I guess what we'll do next week is we'll just kind of do some puzzles, practice with this stuff, try to get our properties down, and probably be looking at a quiz maybe around Wednesday next week. All right. If you are listening, I appreciate your time. Remember that little challenge I gave you, and good luck. And I'll see you guys on Monday.